Hi there, you're looking at my pi-topCEED, and as you can see it's got a pi-pulse fitted in there. Unfortunately a rather sick pi-pulse because there's a fault on the speaker, but for what I'm going to do I think it'll be adequate. And up at the top we're running Raspberry Pi version 3.0 because I have got installed on here the stretch version of Raspbian, which is the next version due out shortly. And that enables me to run Sonic Pi 3 on it. And the reason I'm doing that is because Sonic Pi 3 is capable of sending OSC messages. And by writing a little Python program which is receiving these OSC messages, and then by fitting in the same program the commands to drive the LEDs inside the pi-top, we can end up with some exciting displays, all controlled by Sonic Pi. So what I'm going to do is just to close the window here, because it'll actually make it easier to film, and also to make it a bit more easy to see the LEDs. I'm going to turn off the lights, and then we're ready to go. So the program is already loaded up into Sonic Pi, and we can take the mouse here and come up to the run button at the top and push that, and here we go. Sorry for the sound, but all of these LEDs have been controlled by commands coming from the Sonic Pi program, which is running at the top here, and playing samples as well. So it's making music and it's controlling the LEDs. And as the program goes on, it's going to get faster and faster. I've got 3 commands, one which will set an individual LED to a particular color, one which will set all the LEDs to a single color, and one which will clear all of the LEDs. And these are simply being sent from Sonic Pi to the software which is controlling the LED array here. The whole thing synchronized nicely together. And there it finishes. Well, we're going to do it again in a minute, because sitting beside the pi-topCEED I've got my trusty MacBook Pro, and it's got exactly the same program running on it, and we don't have to change anything because the address as to where all these messages are going to be sent is right at the top of the program, the very first line. It says use OSC, that's the address where it's going to send things to, of 192.168.1.238. That is the address of my pi-topCEED, and to port 8000. And you can see on here exactly the same thing here, and that's going to be received by means of a Python program which is running in the background here, and it's going to actually print out the data which is received from each of these OSC messages sent. The number stream gives you, first of all, the number of the LED which is going to be, the X and Y coordinates of the LED to be altered, so X5 and Y3 there. Then it's going to set the RGB values to 123, 129, 46, and so on all the way down. You'll see another command at the bottom saying clearing LEDs, and there'll be another one right at the top there, set all LEDs to that particular RGB color. And that's really all that's necessary to do this, and that's interfacing to the code which is supplied with the the software package which drives the LED array on the Pulse. And so by doing this we can have the two operating together. So I'm going to run the program again with slightly better sound coming from the Mac here. And if we start that running, it will immediately start to affect the Pulse display. So here we go. Slightly better sound. You can see the LEDs turning off each time a note sounds, a LED is turned on. It might be all the LEDs, which will happen in a minute. And each column has a different synth playing it. And the pitch, it depends on how high up or how low down the note is. You can see the data coming in here. You come to get a bigger view of the end here. So you can see this can all be done by remote control. That's one Mac running Sonic Pi, controlling the pi-topCEED display here. And I'm only scratching the surface because there are lots more commands which can be used to interact with the LED array here, and so over time it can increase what it can do and we can get some really groovy interactions. And there we have it. So a nice new bit of kit from pi-top, the pi-topPULSE, and nice new Sonic Pi version 3, which is aptly named the I/O version because it lets you interact with input and output devices, and so it's incredibly versatile in what it can do. Thanks for watching.